Here is integrated 3. It's CL10-199. It says the graph of f of x equals this cubic is shown at right. Use it to determine all the zeros of the function. So when I look at the cubic, I see that it has a root or a 0 at 1. So that tells me that x minus 1 is a factor. Okay, so I'm going to do Polydoku, and which is just polynomial division, and I'm dividing by x minus 1. And so I start out by putting my x cubed up in the upper left, and then I went x times something is x cubed. Well, x times x squared is x cubed. And then x squared times negative x is, or x squared times negative 1 is negative x squared. Now I know these two boxes have to add up to the x squared term. So I think this needs to be a 4. And then that makes this have to be a 4x because they have to multiply to make what's in the box. And then negative 4x. And then these diagonals, this one and this one, have to add up to make the x term. So they have to add up to make 1. So I think this is going to be 5x. And that forces this up here to be a 5. I got extra parts. So that tells me that this cubic could be written like this. Because if I multiplied that back out again, I'd get that cubic. So this I can already tell by looking at it that there's a 0. You know, when I plug in 1, I get a 0. So that gives me x equals 1. But what does this give me? Well, I would try to factor it, but I know it's not going to factor nicely because I see that it has complex roots. So I'm just going to use the quadratic formula on it. I think it's negative b plus or minus where I guess a equals 1, b equals 4, c equals 5. Okay, we'll plug them in there. So this will be plus or minus, the square root of 4 is 2, and the square root of negative 1 is I. So it'll be like that. And then I can cancel 2's. So this will be 2, 1, and 1. So it'll be negative 2 plus or minus I. So there's all the roots, or all the answers. Okay, you could just leave it as negative 2 plus or minus I if you like it that way, like that.